Hello guys, so today we'll be talking about statistics and we'll see what role it plays in data science study, and also we'll talk about what are the different types of statistics. So let's start. So let me start quickly. So what is statistics, guys? So before I come to the definition, let me explain you with the diagram. So suppose you have data, okay, you have raw data, and our goal is to describe that data and come up with some meaningful information. For example, you have employee salary data, and I want to know, okay, what is the average salary company pays to his employees. So that average salary is kind of information, okay, and in whole raw data, like this information is available. We just need to extract that information, and then with the help of that information, we need to generate some kind of reports, right, for further decision making, which helps a company to better plan their expenditures and to be competitive in the market. So that see what happens in the organization, like many times employee keep on switching from one company to another company, and one of the main reason is salary, right? So that company try to be competent with the market, and they try to meet the salary expectations from the market, so that employee don't leave at least from by this reason, right, because of this reason. So that's why to analyze that HR data, this is very important with respect to the company aspect. So that's why, if we have HR data here, raw data, and we want to extract some meaningful information, like what is the average salary, what is the average experience of the employee, how many employees are in a particular department, okay, so like all sort of information, and then based on that we need to generate some reports. So for that we need to apply some procedures, some methods on that data, right? We need to process that data, then only we'll get this information. So that processing of that data, so what are the different methods we apply, that comes under statistics. So now statistics is nothing but it is all about summarizing and describing your raw data, and then converting it to the meaningful information, then deriving some reports, okay. So this is one aspect of that. And then again, from that report, suppose if we want to draw some conclusion about future, right, we want to predict something about future, then that is another aspect of statistics. So we'll see. So these two aspects will divide in two categories, like one is the descriptive statistics and one is inferential statistics. So that's written here, okay. So this is about statistics. Now let's understand it more from the some data point of view. So suppose, as I was telling, we have a HR data here, okay. So in HR data, suppose there is the age of the employees, and business travel, department, distance from home, education field, employee number, environment satisfaction, gender, right. So this different information is available, and based on that, we have one more attribute like attrition. So whether employee has left the organization or not, right. So this is the information available, and now our decision makers are interested, okay, what is the ratio of the frequent traveler, who is getting the on-site opportunities, like who is traveling frequently, okay, based on business travel column, or who is traveling rarely, okay. And suppose we want to combine the business travel with department, and I'm interested, or decision makers are interested to know, okay, which department is giving more business travel opportunities to his employee, right, or in another word, like in which department more employees are traveling on site, right, or in which department less employees are traveling, or what age group are more traveling, so that sort of information, right, or in employees belonging to which education field, like in which department which education field people are there, right, or suppose sales require more of kind of marketing experience, okay. So in sale, whether people from marketing experience, marketing field are available or not, so that their department and their education field is rightly mapped or not, right. So that sort of study we need. And so how we will do that study? So that's where we apply statistics. So that's it. If you apply statistics procedure, and then you get some kind of this descriptive measures. For example, what is the average age in your company? What how far from how far employees are traveling from their home? What is the average distance from home, right? What is the employee number, what is the average monthly income, and then we have some standard deviation as well, and the minimum age and maximum age, mean and 25 percentile, 50 percentile, 75 percentile data, right? So like for 25 percentile, okay, so bottom 25% of data lies within the range of 30, right? So like so for bottom 30%, 25% data, maximum age is 30. So that's what it tells. But these all I'm going to describe one by one, okay, in later videos. Okay, so here this is a kind of like some descriptive statistics, but this is also some sort of like numbers are mentioned in front of you, right? So not much informative, right? So what statisticians does basically, he draws some kind of reports and graphs, plots, charts, okay? So that's why like if I'm interested to know, okay, what is the gender distribution in my company, so what is the ratio of male to female, so we can draw a beautiful chart like 60% male are there and 40% female are there. But suppose we have this kind of data available, then it becomes very difficult to identify. Okay, of course data is available, age and gender, right? But it is very difficult to immediately tell, okay, what is the male and female ratio in the company, right? So if we have this kind of plots available, then it becomes very easy to understand, right? And similarly, suppose I'm interested like distribution of business travel, like who travel rarely, who travel frequently, and who don't travel at all, right? So around 71% employee travel rarely, and then we have attrition distribution, like okay, so around 84% so not leaving, I mean they are not potential candidate to leave, okay, and 16% attrition is there, so 16% employees are leaving on an average, right? And then if we talk about like department wise attrition, so what is the attrition in different department basically, right? So suppose there is a R&D department, in R&D department like 9% attrition is there, right? And in the sales department around 6% attrition is there, in HR department very less attrition is there, right? But overall people are also less, right? So this sort of analysis you need to do. And then if we talk about like some more insight, for example business travel with respect to attrition and with respect to education field, okay, so we can combine multiple columns and we can come up with some reports, some charts, and from that charts we can like draw some insights, right? So that's where statistics is very helpful basically to describe and summarize your data. So that's where statistical procedures comes in place, right? And now, so this is all about describing and summarizing. So this becomes your descriptive statistics, okay? But when we try to conclude something, when we try to infer something for future, then it becomes inferential statistics. Okay, so let me explain. So what we have done till now, so basically we did two things, like we try to understand, for example, what is the gender distribution, what is the distribution among on-site travel, what is the overall attrition rate, what is the attrition in each department. So these sort of questions analysis we did in terms of charts. And then we also try to understand, okay, based on above study, we try to predict what is the attrition in future. Okay, we can predict with that. So that's where comes like inferential statistics. So let's understand that also. So suppose we have a population of that complete company employees, okay, so that denotes our population. And then if we draw a sample out of that population, like we fetch the representatives from different department, different education field, okay, different area of work, okay, and derive the sample. Then whatever statistical procedure we apply to understand this sample, okay, so that becomes your descriptive statistics. So descriptive statistics is all about gathering the data from sample and describing the same sample. So that is your descriptive statistics. But when we start like generalizing whatever we have learned from the sample, when we generalize that thing, then it becomes inferential statistics. So inferential statistics tells everything about the population, and descriptive statistics tells everything about the sample. So that's where I've written like data gathered from a sample and the statistics generated to reach the conclusions about the population. So that is your inferential statistics. So it is all about generalizing and predicting for future, and descriptive statistics all about summarizing of the data. Okay, so this is your inferential statistics. And of course for inferential statistics you take help of the probability theory. So that's where like probability theory comes in between descriptive statistics and inferential statistics. So this is all about descriptive versus inferential statistics. Now I hope it will be at least somewhat clear, like, okay, this is very important for data science field, because in data science what we do, we try to analyze the data and then learn about the data, we prepare the reports, and also we want to predict for the future, right? So that's where like statistics comes very handy. I mean, this is very, very important. So that's all about statistics, and it's two types, and yeah, so thank you.